Hello everyone, welcome to this video. In this video, we'll be looking at the third property where we are talking about the properties of subgroups under homomorphisms. So here, the third property tells us that if H is given to be an abelian subgroup, right, then the image phi of H is also abelian in nature. So we know that H is an abelian subgroup, right? So that means if you take any two elements within the subgroup, then they would commute with each other. So AB would be equal to BA, right? Next, we wanted to prove that this phi of H is also abelian. So that means here we have to take two elements. Those two elements I have selected to be phi of A and phi of B. Now we will check that whether this is equal to phi of B phi of A or not. If yes, then we would have our subgroup as abelian. Which one? Phi of H would be abelian, correct? So here, to prove that phi of H is abelian, we consider phi of A multiplied with phi of B. Let's see what is this. Now because phi is a homomorphism, you can write it like this, phi of AB, right? Now because AB both are members of capital H, right? So therefore they would commute, hence AB is equals to BA. So you can, instead of writing AB, now can write BA. So what is phi of BA? Again, by the operation preserving property, it is equal to phi of B into phi of A, right? So therefore phi of H is also an abelian subgroup, and this is our third property here. Moving forward on to the fourth property. The fourth property says if H is a normal subgroup in G, then phi of H is also normal in phi of G, correct? We have some mapping G phi from G to G bar. We are taking H to be some subgroup of G, right? Now we are saying this H is a normal subgroup of G. Then they are saying its image phi of H is also normal subgroup of phi of G. We wanted to prove this thing. So now because we are given H as normal subgroup, if we take any two elements, one from the group G and one from the subgroup H, right? So we take small g and small h to be two such elements, such that because it is normal, hence G H G inverse would be present in H by the property of normality, right? Now if you take any two elements from phi of H and phi of G, you take phi of small h from phi of capital H and phi of small g from phi of capital G. Then this element phi of small g, phi of small h, phi of small g whole raised to power inverse. This is, now you can by the property of homomorphism, right, you can write it like this, phi of g inverse, and then you can write whole of this term like this, phi of g h g inverse, right? Because this element is present in capital H, hence this complete element is present in phi of capital H, right? So we have proved that if you take any two elements, one from phi of H and another from phi of capital G, and then you would have phi of G, phi of H, phi of G inverse present in phi of H. Hence this phi of H is also normal in phi of G, and this is what we wanted to prove here as our fourth property. So I hope you understood these properties well. Well, that is it for this video. Thank you for watching.